Okay, for example 2, we have a word problem associated with the cylinder. It says the bottom and inside walls of the cylindrical tank shown in the figure must be lined with sheet copper. How many square feet of sheet copper are needed? So first off, interpreting the question, it says how many square feet, what type of thing are we trying to find here?
Total surface.
Or not necessarily total surface, but something about area, right? When I see square units, I'm thinking area. All right, so once I see area, now I need to determine what type of area I'm looking for, and Zach did say total surface area, but it says the bottom and inside walls. All right, the bottom and inside walls doesn't say the top, right? So the total surface area would be the top and the bottom and the walls. The lateral surface area is just the walls, right? So if I'm looking at these things we can find, lateral surface area is just the walls. Total surface area would be top, bottom, and walls. We don't really have a formula here just to find the bottom and the walls, right? So I want to break this up into 2 pieces, all right? What I want is the bottom and the walls. The walls have a formula, right? So if I'm trying to find the amount of sheet copper needed, I need the area of walls, which has a formula which is 2 pi RH. And I want to add that to the area of the bottom. What is the bottom? What type of shape?
A circle.
It's a circle, right? Does a circle have an area formula?
Yeah.
What is it?
2 pi r squared.
Not 2 pi r squared. What's the area of one circle? So if I'm in the world of circles, the area of a single circle is pi r squared. The circumference or perimeter of a single circle is 2 pi r. Right? So the area of the bottom is just a circle, so it's just going to be plus pi r squared. Okay. So again, we're lining the walls and the bottom with sheet copper. This is how much sheet copper we need for the walls. This is how much sheet copper we need for the bottom. We're going to add those 2 areas together to get the total square footage. It says square feet. This says feet. This says feet. Everything's in feet. That's good. The other thing I have to consider again is all the units, all the things we're looking for anytime we're dealing with a circular cylinder is radius and base. Radius of base and height, right? Those 2 things. And you can see radius of base, height, radius of base, everything is those 2 numbers. So I need to establish what these numbers represent. So this is from the center to the edge, so that's a radius. This is from circle to circle, this is height. Right? So the 2 numbers we need for our formula are just going to be staring us right in the face in this picture. So now we substitute what we know. So the amount of sheet copper needed, I'm going to put this letter C to represent that, C for copper. There's nothing magical about the number of the letter I picked. I just picked C because it starts with the right letter. So the amount of sheet copper we need is going to be 2 pi times 5 times 12 plus pi times 5 squared. What's 5 squared?
25.
25. So I could even write pi times 25 here if I want to go ahead and square 5 in my head. Okay. Once I've squared the radius to make 5 squared is 25 here, product plus product, order of operations again tells me that I have to do all this product here and add it to all this product here. So if I'm doing this on a calculator, I could type in 2 pi times 5 times 12, hit equals, and this bit here is going to be 376.9911184. And if I do pi times 25, that bit comes out to 78.53981634. And once I get both those products figured out, then I add those 2 answers together to get the final answer. So 376.9911184 plus 78.5398111634 equals, and we get 455.5393. course, that's gonna be square feet, right? Right, but it says how many square feet of sheet copper are needed, round to the nearest tenth. So this time they're actually giving us rounding rules. So if I'm rounding to the nearest tenth, this is tenths, the next digit after that's a 3, so we're gonna keep it the same. So the correct answer, rounded to the extent they want to be rounded, is going to be 455.5 square feet of sheet copper needed. So for today's lesson, these are the formulas we'll use. You need to identify those two dimensions in order to use any of those formulas. Once you apply the formula, then you simply calculate. The only thing I'd caution you again with when you're evaluating with a calculator is r squared happens before 2 pi, r squared happens before pi and h. So make sure that r squared is done first before you punch in your calculator.